Okay, so in this example, we see here two functions, so x plus 1 and ex. So what we will do is we will use the product rule. So if you use the product rule, x plus 1 times ddx of ex plus ex, and then ddx of x plus 1. So then we have to understand this block and the block over here. So ddx of ex would be ex, so that is base case number 2. So this one, if you split ddx of x, would be 1, and plus ddx of 1 would be 0, so it's just 1. So the answer would be ex x plus 1 plus ex. So if you want, you can take ex out, then you get x plus 1 plus 1. So that's going to be ex x plus 2. So that's the answer to that question. Okay, so in this question, again you have two functions, so we will apply the product rule. So that would be 2x plus 1 square, then ddx of x plus 1 squared plus x plus 1 squared, then we have ddx of 2x plus 1 squared. So now there is a easy way that we can sort of do this, but for now I will expand it and do. So that would be 2x plus 1 squared. Here you get ddx. If you expand it, you get x squared plus 2x plus 1, and then plus x plus 1 squared. And if you expand this one, you get 4x squared plus 4x plus 1. Now you have to find this one over here and this one over here. So when you take the first derivative over here, so ddx of x squared, so you can use the addition rule. When you use the addition rule, and if you individually consider the derivative, you get 2x plus 2 here. Here you get 8x plus 4. Now what you will do, you will just multiply. So it's going to be 2x plus 1 squared, and here 2x plus 2 plus, here you get x plus 1 squared plus multiply with 8x plus 4. So now you will see you can factorize this. So you can write this one as 2x plus 1, and you can keep 2x plus 1 squared here. Then you can factorize this one, that would be 2x plus 2. So if you take 4 out, it's going to be 2x plus 2, then you get x plus 1 squared. So now you can see 2 is common, x plus 1 is common, and 2x plus 1 also common. So if you take those things out from the first term, 2x plus 1 is what is remaining, plus 2, here x plus 1 is what is remaining. So here you can simplify this to x plus 1, 2x plus 1, and then here you can get 2x is 4x, and 1 plus 2 would be 3, so plus 3. So that will be the answer to that question. So in this question we can see a division, right? So we can see a division as well as a multiplication. So what I will do, I will consider this to be a division first. So then what I will get, x squared plus 1, the whole thing to the power 2. Then I will get x squared plus 1 and take the derivative of x squared ex, then plus x squared ex, then take the derivative of x squared plus 1. Now we have to find this. I would say first one. Secondly, I have to find this. That's my second one. Now I will take the first one. Then you can see it's a product. So I use the product rule, x squared ddx of ex plus ex, then ddx of x squared. Now the answer to this one would be ex x squared plus, then I have 2x ex. Okay, 2x ex. Now the second one would be ddx of x squared plus 1. So that would be is equal to just 2x. So now what I can say, I can write now x squared plus 1, then I have ex x squared plus 2x ex, then I have 2x x ex, the whole thing divided by x squared plus 1, the whole thing to the power 2. So that's the answer. So all the derivatives are done. Now you can simplify this further, but I'm not going to do. It's just algebraic simplification. Okay, so now here fx function is given to you 3x squared plus x plus 1. You need to find f dash x and f double dash x. So firstly we will find f dash x. So you know f dash x is nothing but ddx of fx. So if you do that, you can say this is very easy. So it's going to be 6x plus 1, right? So now f double dash x. So we know f double dash x is ddx is, you know, operating 2 times. So ddx of fx. So now you already know this, that is this. So that would be ddx of 6x plus 1, and the answer would be 6. Now if you want to find f dash 1, so you know f dash is you have already here. So f dash 1 would be f dash x. This is evaluated at x is equal to 1. So that is equal to 6 times 1 plus 1. So it's going to be 6, 7. Okay, so that's how you do that. So in this question, first of all, we will find what is gx minus fx. So gx minus fx would be, so I will simplify this one, x squared plus a squared minus 2ax, right, minus 2ax, then fx, so minus x squared minus a squared. So you can cancel these two off, you can cancel these two off, so it's very easy now. So this is nothing but ddx of minus 2ax. So you can take minus 2a out, so it's going to be ddx of x, which is 1, so it's going to be minus 2a. So that's the answer to that question. So now in this question, so first of all we have to consider ddx of gx, so we have to break the problem first. So first we will find ddx of gx. So ddx of gx, so that would be ddx of x squared minus 2ax plus a squared. So when you take the derivative of this one, this is going to be 2x minus 2a. Now if you have ddx of gx minus fx, so fx would be, okay, it's written here, so it would be 2x minus 2a minus fx, that's going to be this, right? So now we have that term. Now we need to differentiate that. So ddx of, now we have ddx gx here minus fx. Okay, so once we have that, so that means we have to differentiate this one. So ddx of 2x minus 2a minus x squared minus a squared, this one over here. So that would be equal to 2, so this is 0 because it's a constant, minus 2x, this one also 0 when you do ddx on that. So the answer would be 2 1 minus x.